about how to graph logarithmic functions. Remember that logarithmic functions and exponential functions are inverses. Okay, so look in blue here, we have the exponential function f of x equals 2 to the x graphed. In red here, we have the logarithmic function g of x equals a log base 2 of x. So notice that this graph is reflected over the line y equals x. Also notice that the coordinates in the table of values are reversed. The x values become the y values and the y values become the x values. So remember that these are both characteristics of inverse functions. Also, if we look at these graphs, notice that the domain of the exponential function is all real numbers. The range is all numbers from 0 to positive infinity, and it has a horizontal asymptote at y equals 0. The logarithmic function has a domain from 0 to infinity because the range of the original function will become the domain of the inverse, right? And also the range is going to go all real numbers from negative infinity to positive infinity because the domain of the original function becomes the range of the inverse. Also, the horizontal asymptote will switch and become a vertical asymptote, right? So instead of having an asymptote at y equals 0, it's now going to have an asymptote at x equals 0, right? Which is this line right here. So when we graph log functions, remember that they have the form f of x equals a log base b of x. So as we change the value of b, depending on what it is, if it's larger, the function is going to grow more slowly. So we also have a domain restriction for log functions. Remember that you cannot take the log of a negative number. So if we're graphing like f of x equals a log base b of x, remember that the domain will be restricted so that x is greater than 0. So here's how we graph log functions. You're going to start off finding the x and y intercepts of the graph. Then you're going to create a table of values to find the other ordered pairs, find the vertical asymptote in the domain, graph the vertical asymptote, and then graph the ordered pairs as smooth curve. Okay, so now let's graph the function f of x equals a log of x and name its domain and vertical asymptote. So we're going to start off by figuring out the x and y intercepts. Okay, so remember the x-intercept will occur where y equals 0, right? The x-intercept has the form x0. So I'm going to go ahead and plug in y equals 0 to this function. So I have 0 equals the log of x. Remember that the log of x is the log base 10. So just to help us solve, I'm just going to write the 0 over here on the right, because now what I can do is I can convert this to exponential form. So I get 10 to the 0 equals x. Well, 10 to the 0 is 1, so that tells me that 1 equals x. So that means that I have an x-intercept at 1, 0. Now let's figure out the y-intercept. Remember, the y-intercept is going to occur where x equals 0. So I have 0y. So if I go ahead and plug in x equals 0 to this function, I have f of 0 equals the log of 0. Well, we can't take the log of 0. Okay, if you try this on your calculator, you'll notice that it gives you an error message. And remember, we were restricting this function so that x is bigger than 0, okay, not equal to 0. So it does not actually have a y-intercept, okay? So since we can't solve this, this has no y-intercept. So now let's go to the next step and fill in a table of values. So we have the first value, which is x equals 1. Well, we already found that. That is actually the x-intercept of our function. So at x equals 1, y equals 0. So now I'm just going to go to Desmos. And what I'm going to do here is you can just type log of x. And we're going to find those other points that it's asking for. So it's asking for 3. So at x equals 3, if you click on that point, it says 0.477. And then it asks us for x equals 10. If we click on that, you can see that it is at 1. Okay, so we can get exactly to that point. There we go, 10, 1. Okay, so now let's go ahead and fill in our table. So we have 3 and we have 0.477 and we have 10, 1. So let's go ahead and graph. So 1, 0 is going to be here because remember that's our x-intercept. And then we have 3 and then 0.477, so a little bit below a half. And then we have 10, 1. Okay, so we also want to think about the vertical asymptote of this function. Okay, so where is the vertical asymptote going to occur? Well, let's look at this graph. So you can see here that this is once again going to get close to x equals 0, but not actually cross it, right? If you zoom in, you can see it's going to get really, really close to that y-axis, but it's not going to actually cross. So we know that it has a vertical asymptote at x equals 0. Okay, so my function is going to get really, really close to that, but not actually cross it. So let's go ahead now and connect these points and create a curve. So when we do that, it kind of looks like this. We can draw that a little better. Let's see. Connect the points, and then you're just going to get really, really close to the asymptote, but not actually cross it. There we go. Okay, so now it also wants us to describe the domain and vertical asymptote. So we did find the vertical asymptote, so let's go ahead and describe the domain. So notice that the domain starts at 0, but then it keeps going to the right, okay? So it's going to go from 0 to positive infinity, and that is the domain of this function. Okay, so now let's try graphing f of x equals a log of x minus 1. So once again, let's start off with the x and y intercept. So the x-intercept is going to be where y equals 0. So we have 0 equals log of x minus 1. So we're going to go ahead and solve by adding 1 to both sides. So we have 1 equals the log of x. Once again, this is the common log, which is base 10. So I'm just going to write that 1 over here. And then I'm going to convert it to exponential form. So we have 10 to the 1 equals x. 10 to the 1 equals x means that 10 equals x. So our x-intercept is going to be at 10, 0. Now let's figure out the y-intercept. So the y-intercept is going to occur where x equals 0, right? So we have 0y. If we plug into this function, we have f of 0 equals the log of 0 minus 1. Once again, we're trying to take the log of 0, so that won't work. So there will be no y-intercept. Now let's go ahead and graph this using our table of values. So we have the x values of 5, 10, and 15. Notice that x value of 10 is actually our intercept. So we can go ahead and fill that in. We have 10, 0. And then let's figure out what's going on at 5 and 15. So I'm going to once again go to Desmos, and we already have the log of x typed there. So I'm just going to do the log of x minus 1. And I'm going to zoom back out so we can see our graph. So we're trying to find the values at 5 and 15. So at 5, we're here at negative 0.301. And at 15, if we go here, we're at 0.176. Okay, so let's go ahead and enter those values in our table. So we have 5 and negative 0.301. And then 15 and 0.176. So 5, negative 0.301 is just about like a third of the way down. We have 10, 0, our x-intercept, and we have 15, and this is just going to be a tiny bit above 15. Okay, so once again, we have our vertical asymptote, which is at x equals 0, right? So that is going to be our vertical asymptote. And then let's go ahead and graph our ordered pairs. So if we connect these using a curve, kind of looks like this. And then I have that asymptote here at x equals 0. So it's going to get really, really close to that, but not actually cross. So there we go. And then now we can describe the domain. The domain is going to include all real numbers from 0 to positive infinity, right? Because it doesn't cross x equals 0. Okay, so now let's graph this function and name its domain and vertical asymptote. So we're always going to start off by finding the x-intercept and the y-intercept. So the x-intercept will occur where y equals 0. So we have 0 equals 2 times the natural log of x plus 1. So to solve this, I'm going to go ahead and divide both sides by 2 so that I can get that natural log by itself. So that gives me 0 equals the natural log of x plus 1. So now to solve this, I'm just going to write the 0 over here. Remember that the natural log is basically the log base e, right? So this is the log base e of x plus 1 equals 0. So to solve this, I'm going to exponentiate this, and this is going to turn into e to the 0 equals x plus 1. So e to the 0, remember anything to the 0 power is 1. So I have 1 equals x plus 1. And now I can solve this equation by subtracting 1 for both sides. So when I do that, I get 0 equals x. So that means my x-intercept will be at 0, 0. So you may notice that this is also going to end up being the y-intercept, right? Because the y-intercept occurs where x equals 0. But we can actually just plug in just to see that that's in fact true. So if I plug this in, I get f of 0 equals 2 natural log of 0 plus 1, right? So that gives me f of 0 equals 2 times the natural log of 1. So the natural log of 1, remember, is 0 because anything to the 0 power is 1. So this is 2 times 0, which tells me that f of 0 equals 0. Okay, so the x-intercept and y-intercept are both at 0, 0. So now let's figure out from our table of values how to fill in the rest of the graph. So we first have that point 0, which we did find was the x and y intercept. But now let's go to Desmos. So we have 2 natural log of x plus 1. Okay, so now here's our graph. So let's find those other x values that it was asking us for. And it was saying x equals 1. So x equals 1, we're right here, 1.386. And at 3, $2.773. Okay, so now let's go back and fill in our table. So we have 1.386, and then 3, 2.773. So 0, 0 is the x and y intercept, and then we have 1.386, and 2.773. So about right here. Okay, so now let's go back and look at the graph so we can see what it looks like. Okay, so it kind of looks like this. Notice it has a vertical asymptote at x equals -1. So that's an important thing to keep in mind. So at x equals -1, that's where we have our vertical asymptote. And remember, you can find that looking at the equation, right? Remember what we're going to say is that x plus 1 is greater than 0 because we can't take the log of a negative number. And if you subtract 1 from both sides, you'll see that x is greater than -1. So that's how we get that vertical asymptote at x equals -1. So I'm going to go ahead and I'm going to connect these points. And that's sort of what my graph looks like, right? So that's my graph. Notice that it has a domain that goes from -1 to positive infinity. Okay, so now let's graph this function and name its domain and vertical asymptote. So we're going to start off by finding the x-intercept and the y-intercept. So the x-intercept is at x, 0. So we're going to plug in 0 for y, so we have 0 equals the natural log of 4x. So I'm just going to write this on the other side. So I'm going to have the natural log of 4x equals 0, right? So that tells me that the log base e of 4x equals 0. And then let's write this in exponential form. So we have e to the 0 equals 4x. So that tells us that 1 equals 4x, and we can divide both sides by 4. So that tells us that 1/4 equals x. Okay, so 1/4, 0 is the x-intercept. Now let's figure out the y-intercept. So the y-intercept will occur where x equals 0. So we have 0, y. If we plug in x equals 0, we get f of 0 equals the ln of 4 times 0. So that tells us the natural log of 0, which once again we can't take, right? This 4x has to be greater than 0. So we don't have a y-intercept, but we do have an x-intercept. So now let's go to our table of values and figure out the rest of the points on the graph. Okay, so at x equals 1/4, we know that's where we have our x-intercepts. That's going to be 0. And we just need to figure out the values at 1 and 3. So let's go back to our graph. Let's do the natural log of 4x. And at 1, we are here, 1.386. And then at 3, we are here, 2.485. Okay, so let's go back to our table. So we have 1.386 and 2.485. So 1/4 0 is going to be like here. 1.386 is going to be here. And then 3, 2.485 is like a little bit up here. Okay, so once again, if we look at Desmos, we can see that we have a vertical asymptote at x equals 0, right? Which we can also figure out because you would say that 4x has to be greater than 0, which tells us that x is greater than 0. Okay, so this y-axis is going to be our vertical asymptote. So if we connect these points to form our graph, it's going to look kind of like this, right? Get really, really close to the y-axis, but not actually cross it, and it's going to go like this to the right. So we would say the vertical asymptote is x equals 0, and we can say that the domain is going to go from 0 to positive infinity. Okay, so you can graph a logarithmic function using the following steps. First, find the x and y intercepts of the graph, then create a table of values to find the other ordered pairs. Find the vertical asymptote and domain, then graph the vertical asymptote and graph the ordered pairs as a smooth curve.